There is a prescribed experiment for Newton's second law, and it involves using something called a ticker timer. So I'm going to show you how a ticker timer works. First, you need a little bit of a power pack, and then you have this ticker timer going, and you put a trolley on it. The ticker timer itself has got this carbon paper in it. You thread the tape through there, and now this piece of tape gets attached to the back of a trolley, like that, and as this trolley moves, this thing goes and makes dots on the tape. So that's going to be powered. Turn it on. As the trolley moves, it creates dots. This little thing makes dots on the piece of tape. And you can see the little dots over there. Now the dots make you look at the spaces between those dots to see if something's going fast or slowly. If you look over here, the spaces are very small. In other words, the dots are close together, and therefore that is moving slowly. As the dots get further and further apart, so the trolley is moving faster and faster. Now let's take a look at how the experiment actually unfolds. What you do is you'd set up a ticker timer, and you've got a ruler. By the way, this experiment really doesn't work very well, but we'll tell you the theory of it anyway. There's a ruler, and you then set this elastic band to, let's say, 12 centimeters. And you pull the trolley with the exact same force on the elastic band. Then you put 2 elastic bands there and do exactly the same thing, and then 3 elastic bands and do exactly the same thing. So the theory is that you would have 1 times the force, then with 2 elastic bands, 2 times the force, 3 times the force, etc. And each time you pull this trolley along and keep the ruler holding the perfect length of that elastic band. Very, very difficult to do. Anyway, but that's the setup of it. What comes out is I'm going to give you some data that is ideal data on this particular experiment and show you what you're supposed to learn from it. Obviously, we're trying to look at Newton's second law. With Newton's second law, it is a relationship between force, the force on 1 elastic band, 2 elastic bands, 3 elastic bands, 4 elastic bands, and the acceleration produced on this trolley. In other words, by how much does this trolley speed up? Let's see what we get. This is an imaginary piece of tape that would come out of there. The frequency of the ticker timer is 50 hertz. What does frequency mean? Frequency means number of dots per second. So how long does one dot, or rather, what we're actually interested in is one space. The space is what takes time to create, not the actual dots. So the time is going to be 1 over 50, which turns out to be 0,02 seconds. We then get told some distances, 2 millimeters, 4 millimeters, 6 millimeters. So that space is supposed to be 2, that is supposed to be 4, that is supposed to be 6, that is supposed to be 8, that is 10, etc. So the spaces are getting further and further apart. In other words, this is going faster and faster. It is an accelerating thing. They say find the velocities at B and F and then find the acceleration of the tape. Now this is quite a tricky thing. What you have to do is you have to work out if you want to find the velocity at B, you need to work out the velocity from A to C. If you want to find the velocity at F, you need to work out the velocity between E and G. So if we work out the distance from A to C, it's going to be 6 millimeters. And 6 millimeters is going to translate into 0,006 meters divided by what time? Each space takes 0,02 seconds to make. So to get from A to C is 2 spaces, so I divide that by 0,04 seconds. And we get 0,15 meters per second. That's the starting speed. Where is it true? It's true at B. The next thing we do is we go and we take a look at F. for F we have to go from E to G, and from E to G is going to be 22 millimeters. So it's 0,022 meters. Again, there are two spaces, 0,04 seconds. And I land up with 0,55 meters per second at F. Now, if I'm trying to work out acceleration, remember acceleration is equal to final velocity minus initial velocity divided by the change in time. Change in time, 1 space, 2 space, 3 space, 4 space, and those 4 spaces mean 0,08 seconds. I get an answer of 5 meters per second squared. So I've now got an acceleration. Now if I repeat this with 2 elastic bands, with 3 elastic bands, with 4 elastic bands, so the force in newtons, or the number of elastic bands, 1 band, 2 bands, 3 bands, 4 bands, etc. And I work out the acceleration each time. This graph does not correlate with this data exactly, okay, so it would have actually been on 5, and we would have had, well, it could be a force of 2,5 newtons and an acceleration of 5 meters per second squared for this particular data. If I now say I'm interested in finding the gradient, I would say change in y, change in force over change in acceleration. Let's just take a look at that. If I'm going to say force divided by acceleration, let's remind ourselves force is equal to mass times acceleration. So if I've got force divided by acceleration, that is equal to the mass. Change in force over change in acceleration is going to give me the mass. So a graph of force versus acceleration is going to give me a gradient of mass. The fact that I get a straight line graph means that they are, force and acceleration are directly proportional to each other. And remember what the Newton's second law is, that if a body is accelerated by a force, that force will be directly proportional to the acceleration. So, if we recap this section, you're going to have to know how to interpret pieces of ticker tape. You are also going to have to know how to interpret force versus acceleration graphs. You're going to need to plot graphs, read off graphs, and determine the gradient of the graphs. And from that, you need to be able to take that information into the concept of Newton's second law, which is that if a body is accelerated by a force, that force will be directly proportional to the acceleration. The other thing that we need to know is that we need to remember how to work with ticker timers. If we're given the frequency of a ticker timer, we need to work out the period of that ticker timer, and we do that by inverting the frequency. Period is 1 over frequency, and that gives me the time for one space to be created. I then will always take a look at distance over time. Distance over time to get velocities, a starting velocity, an ending velocity, and then I must be very careful. Where is it true? In the middle of the distances, in the middle of the distances, and I land up then being able to calculate acceleration. Acceleration is change in velocity over change in time.